Hello, everyone. I'm really honored to be speaker at this conference, second year in a row, so thanks for the organizers. And this time, I'm going to talk about things I actually do at my daily job, because usually it just happens so that I do the talks about my side projects and tech that I'm interested in, but this time I'm going to talk about challenges that I tackle daily. So it's going to be about big data technologies, specifically in AdTech domain. I'm Roksolana. I work as big data developer at Captify, and Captify has an engineering team divided between London and Kyiv, and I'm based in Kyiv. Also, I'm diversity inclusion ambassador there, Women Who Code Kyiv data engineering lead at the local community, and I often speak at conferences and meetups. So first of all, I'm going to talk a little bit about big data in general, what AdTech is, what kind of issues happen in this domain, what is Captify in the concept of AdTech, and then I will move more to the practical examples, like the problems that I had to solve and the approaches that we use to solve those issues. Obviously, it's not the only way to solve such kind of problems in terms of big data. There are many approaches, so I would be happy to hear about your experience if you had something. So please share or ask questions after the talk as well. And in the end, we'll draw some conclusions out of that. So first of all, big data. I think that big data is quite a hyped word recently, and most of the people associate big data with volumes of data, while in reality, it's only one of the concepts around big data. So talking about big data, there's usually this theory called 5 Vs, because there are 5 dimensions which describe big data very well. First of all, it's volume. So definitely we are talking about the amount of data that we have, but there is no such thing as kind of a limit from which we can say that it's big data. We can say, for example, like 1 terabyte, it's big data. Lower than that, it's not. But a good approach here would be to actually understand whether we can process this data on one node of the cluster. In the case if we can't do that, usually it's big data, because we need to use distributed systems for that. Another aspect is variety. So big data usually has all kinds of types and formats in terms of schema and formats of the files. Also veracity, which is about trustworthiness of the data. So we don't need to have some empty records or like random values out of the ranges. We need to rely on our data and to have proper and expected values. Another important concept is velocity. So you would usually process static and dynamic data differently. For example, we usually call that batch data processing and streaming data processing, which I think can be familiar for many people. So with batch approach, you would work with kind of batch of records, one at a time, and you don't have strict time constraints. While with streaming data processing, you need to process each record at a time and in nearly real-time fashion. And the last but not least is value. So we usually need to draw some value out of our data, because we use this data to achieve some goal. So kind of tech landscape of big data looks like this, but obviously you don't use all kind of frameworks like on this slide, or all kind of programming languages in one project. You can choose like one relational database, one non-relational database, 2 frameworks for like streaming and batch processing, or combine it in one. And you can have 1 or multiple programming languages. So these are kind of choices that you usually have. And it's amazing to have such a choice, diverse one. But at the same time, it can be a challenge to actually solve an issue when you have so many approaches to it, I would say. So now moving to the question of AdTech. What is AdTech? Well, I think most of you understood already that it's about advertising, and how it's different from like usual advertising is that AdTech allows to kind of build more personalized ads for users. So usually if you would see some ads on the TV, you can get recommendations about the products you're not interested in at all, because you just see all of the ads on the TV. While when you are scrolling a website, you can get more personalized content. So AdTech kind of allows to use these technologies behind the scenes, which would understand what you're interested in, basically. So they help to deliver the right content, the right time, and to the right consumer. And Captify in this concept helps multiple brands or clients to run advertising campaigns. So they are able to manage their campaigns, figure out what kind of users they want to run those campaigns on. And Captify does that using user searches. So we kind of have the feed of user searches, which is actually the largest outside of Google. And relying on those, advertisers are able to figure out who they want to sell their product to, basically. Those user searches are very diverse. We also kind of build segments or categories out of users, depending on different things, like age groups, geography, and so on, so that brands would be able to run campaigns, for example, in specific locations or to specific age groups, and so on. But I can't say that there is like group which is age this and this. Usually there are multiple features which build up these segments. They are quite complex. Also, Captify, as I said, has this application which allows to run advertising campaigns. It's called Sense. And one new challenge in advertising domain recently, in the last few years, is that Google is banning cookies, and a lot of campaigns actually run in Google Chrome. And therefore, advertising brands or agencies need to build some cookieless solutions so they wouldn't kind of identify the user directly with a cookie. And Captify built in the last few years a cookieless solution, and it's also great because it's more compliant with GDPR because there is no need to actually track the user. You can just kind of build more contextual approach to it, and you don't know who the user is, so you're not interested in the identity of the user. Now to the question, where is kind of Scala in all of that? And it happens so that all of the backend is built using Scala for the Sense platform, and all of the big data technologies are also built using Scala. So everything around data processing, data storage, and practical examples that I'm going to show are also running using Scala. So talking about specific big data tasks. First of all, there is a task of reporting. So we have analytics team which needs to run different kinds of reports or monthly or yearly basis on all kinds of data that we get. And those reports help them to understand whether brands can run campaigns efficiently. And they need like data around data costs, some brands, some budgets of the campaigns. And in order to do that, they need data. And the big data team kind of provides this data by providing it using a specific tool, which I'm going to show. Another one is the task for running insights. So there is this feature in Sense platform which allows multiple brands to get insights during the campaign run about their campaign and the users. And those insights help them to understand better whether they need to continue running campaigns on the same users or maybe change it up, or maybe in the future run campaigns on different kinds of users. And again, it's based on top of the data. Therefore, big data teams should work on delivering this data to them, which is a bit similar to reporting. And one more very complex task is about data cost attribution. So basically, just in general, we have some kind of data that we need to kind of pay for, and therefore we need to calculate for each of these kind of rows of the data how much we need to pay. And the amount of data is quite huge, therefore the job is complex. One more task is around building user audiences or segments that I mentioned. So we need to actually identify in which way we are going to classify the users. Then we need to store this data somewhere and supply it to the Sense platform. And the last is just all kinds of data processing and storage within the company built using big data technologies. So now I'm going to dive deeper into first three tasks because the fourth one is kind of maps through lots of team, contains like front-end part, back-end part, so it would be too long to explain in a way. And the fifth one is kind of descriptive in itself, I would say. So talking about reporting, more specifically, how it works. As I mentioned, there are many data providers that supply different kinds of data in terms of the business. For developers, it looks like just some feeds that are dropped somewhere on some buckets, and we need to transform them in some way and supply it for other users to query this data. So in terms of the structure, it can look like this. We have some abstract data provider. We have some module for transforming this data, separate module for loading it, and some data storage system. So it's very kind of abstract representation, and it obviously differs from one data provider to another. So in terms of stack, it looks like this. In Captify, we have Amazon S3 bucket, where data providers drop different feeds, and in different formats as well. The most prevalent ones are CSV and Parquet. So we need to, first of all, ingest this data. And behind the scenes, it looks like this. So we have, it's fine. So we have a tool called S3 Lister, which is on top of AWS client. And this tool allows to filter out the files by the dates as much as we need to just ingest them. Then we need to supply the schema usually, because reading from CSV and Parquet without supplying a schema is kind of hard, and we have lots of fields, so we need to specify the types. And one more interesting thing behind the scenes is dates parsing. So all of our feeds rely heavily on dates. We need to supply usually like date, hour, timestamp. And not all of those feeds actually have this data. So sometimes we can have like only date, and we need to generate some timestamp out of it. Or sometimes we can have the date like in the name of the file or in the name of the directory. So we need to parse it out and then kind of move it into the feed that should actually contain this data. So that kind of happens behind the scenes for different feeds. Another part is about data loading. So again, in terms of technologies, it looks like this. There is some Apache Spark job that uploads the data to Impala, and the actual files are stored on HDFS and S3. So Impala is not a database. It's a query engine. So it works in such a way that we can just drop the file to HDFS, which is default file system for Impala. And Impala is going to pick them up and allow the users to query this data. So for the user, it looks like just a database. You can run like select, delete, everything you need. While for us, it looks like just dropping the files to some bucket. But there are some issues behind that as well. So first of all, in order to upload the data, we need to, again, specify the schema, because we actually need to kind of build the table structure as we would do for the databases. And usually the schema is supplied by the end users, because they kind of need to identify which fields they actually need. Then there is a part with actually storing the data on HDFS and S3. So why I actually mentioned S3 here? As I said, HDFS is the default storage system. We use this approach of kind of moving the data from HDFS to S3, or storing the data externally on S3, because for Impala, S3 is kind of external storage, not a default one. And it helped in terms of the volumes of the data. HDFS with Impala is not very good with handling large data volumes. So moving to S3 is a great approach, but there are issues with it as well. So there can be issues around metadata handling. As I said, for Impala, HDFS is a native storage, so you can easily find the data there, while S3, it's external one, and therefore for Impala, it looks like some data out there, and Impala needs to understand that it's actually the data of this table. And therefore, there can be issues with some collisions, some lost files, which happen from time to time. And another part is with the data upload. So usually, the upload to Impala happens in some scheduled times, depending on the end user's needs. But there's time when we just build this job from scratch, and we need to upload everything. And therefore, there can be two separate pipelines with full upload And the others one would be just about kind of filtering out the data, checking the dates that we need to upload only the dates for today, for example, if you run the job once a day. And therefore, these pipelines can be separate, which is also fine. But for some feeds, it works to kind of combine them with the first upload. If you would build a check with like checking the today's data and how much data you have in the database. In such a way, you can either run fresh upload because you have no data, or you can run a scheduled one because you just check how much data you have and how much more you need to upload. So for the challenges about reporting, first of all, it's diverse data types. As I mentioned, there are multiple files of different formats. So we try to build more abstract approach to it. Like there are internal libraries which allow to upload the data to Impala, but there are still a lot of moving features which are different for each feed, like the schemas, sometimes the data types that we need to work on, also the dates issue that I mentioned. Another challenge is time dependency. It's around the dates. So as I said, there can be stored in so many different formats, so you may have to build different approach each time with new feed, even if you have this kind of abstract library which works with the upload to Impala, and it can be challenging from time to time. And also, it can be challenging in terms of the kind of how important this feed is. So if you want to upload the data like 4 times a day, for example, but you have lost it for some reason, you will get like someone coming to you and saying that there is no data, do something about it. Another challenge is external data storage. So that's the issue with metadata that I mentioned, that Impala is not very good with external storage, and it can lose files from time to time. But it's kind of comfortable when you need to drop some data. You just kind of rerun some metadata checks, and Impala finds new data if you want to kind of re-upload something. And one more challenge is about constant connection with end users, and I think for developers it can be a trouble from time to time when there are end users who don't really understand how the pipelines work and how complex they are. So they may come like and say that fix it in an hour or 2 because it's a very important issue, but you know that you can't do that in an hour, especially if the data feed is quite big. Now for the another problem, which is called insights. So as I mentioned, it's a bit similar to reporting because, again, we need to supply the data to the database, in this case, Impala again, and also with data then moves to the front-end part. So for big data developers, it looks like this. We have search data feed. Search data is just searches of the users, so it can be anything like new BMW or something like that. Any like set of words that usually users type in Google search. Then we have a job which is called keywords profiler. So this job classifies if there are some kind of keywords in these searches. In this case, it would be BMW because it helps to understand that it's a car. And then there are 2 parallel pipelines here. Impala loader, similar to reporting, which just uploads the data to Impala after profiling, and Elasticsearch loader, because on front end they connect to Elasticsearch and display it using Elasticsearch. So in terms of stack, first part about keywords profiler looks very simple in an abstract terms. We have Parquet files on S3 bucket, and we run Spark job. Behind the scenes, there are additional transformations. Like we need to extract some demographics data, we need to extract geographical data and build kind of this unified feed with all of that. And then we need to do the data loading. So talking about data loading, we have the part with building this unified feed called time-bounded user profiles because it has information about users, and we call it profiles because it has like demographics and geographical information. And then this feed is uploaded to Impala, similar to the reporting, and stored on HDFS S3. And there is another moving part to it with Elasticsearch. So we have a separate Elasticsearch service. There is a library internally that is built for it, which uploads the data using this specific service to connect to Spark. upload it to Elasticsearch, and then the front-end team can pick up this data. They can run some queries in Elasticsearch to see how it looks like, what insights they can get, or they connect the Sense to it, and then they can display this data in Sense for the clients. So talking about challenges. Same as reporting, because we are working with Impala again, we are working with different feeds. So we basically have the same end users and the same challenges around that. Another challenge arises with Elasticsearch. So actually, Elasticsearch is not very good for big data. It doesn't handle large data volumes very well, and it can crash often because of that. And the approaches to it would be either find a way to kind of display the data a little bit differently, like trimming some fields, maybe displaying only some parts of the data, or uploading it in a different way. But basically, Elasticsearch is not as good as Impala in this case to display large volumes of the data, especially historically. And another challenge is cross-team collaboration. As I mentioned, the data runs from Elasticsearch to front-end part, so we already have a separate team for it. Also, historically, it happened that way that the part with uploading to Impala is in one team, like where we did the reporting. Keywords profiling is in another team, and adding the data to Elasticsearch is like in third team. So if anything happens on one of the steps of the pipeline, it influences everyone, and kind of hard sometimes to find where the problem started. Now to the third case, which is one of the most complex ones. So I just told in like abstract terms what data cost attribution means, but actually talking more about kind of AdTech side of it, we have log-level data. Log-level because there are like multiple rows for every second or millisecond. And the information contains, the information there is about user events. So user events is something we as users do on the website when we see an ad. So these events are classified into clicks, conversions, and impressions. And this user search data is then ingested by us from the data providers. Then we have this module called mapper. So this mapper module kind of adds the schema to it that we need to have in the end. And also it reads up some data from the database additionally to kind of build the joins. And in the end, we have like a huge feed with 40 fields or something. And then comes like the most resource-intensive part, which is transformation. So aside of just building this huge feed, we also need to figure out actually which users are in this feed. So attribution in this case would be the process when the users in this feed actually the same users as in our audiences that we build. So it works in such a way that we just need to check that user ID kind of is the same as in our segments. And in AdTech, it works like this, that actually we've got the users that we mentioned in the campaign to watch the ad. So like we targeted these users and they watched it. That's why it's called attribution. We don't need like users outside of that because it's not the user that we targeted. And how it works in terms of the data costs, the company like Captify pays for each of the events to the data provider, the events that are attributed, which means the events that come from these segments. And the information is stored in some data storage system. So in terms of stack, like the general pipeline looks very simple, but as I mentioned, there are multiple steps to it. So first of all, reading the data from Amazon S3, very different types because we have different data providers and different feeds. Then we do it again with Apache Spark, store the files in HDFS, and in the process we read some tables from PostgreSQL. So in more details, it looks like this, similar to the previous version that I've shown. We read the files from Amazon S3 via so-called ingestion module. This module then kind of moves the data to mapping. Mapping is called in such a way that we build unified feed, and at the same time, we get some information from the database, and then transformation happens. So what happens behind the scenes is that in ingestion, there is already this familiar S3 lister, which helps with data filtering. Why we need data filtering in this case is that we have information for like 3 or 4 years. We don't need to read all of the information each time we run the application. We just need to read only fresh data, and usually end users specify the time period. It can be a few days, a few hours. So we want to read just new data, and then build this unified feed, kind of adding these columns, building this huge feed, reading some tables tables information from our database, which is usually our internal stuff. And that helps us to then figure out which users are in this feed are actually attributed. So in transformation, we actually have kind of 2 moving parts: the transformer with attribution and data cost calculator, which just runs data cost calculation on events via some currency exchange rates for the date. And in the end, we supply this data to HDFS. And actually, this feed also participates in reporting, because we then, again, show this data in Impala. And a lot of, actually, features grow out of this huge feed. Like, for example, we don't only show the raw data to the end users, we also show aggregated data. So we build some additional transformations on data costs, like averages, some sums that users need. And for them, it's easier than to actually run it as a query, because it will take eternity on huge amounts of data. And also, machine learning pipelines are built on top of that by other teams. So challenges around that is that we need to process and store like tremendous amount of data. As I said, this approach is more abstract because we have 3 different implementations for 3 different data providers. They have like abstract way of doing things, like transformer, mapper, and all of that, but they are a bit different depending on the data that we have. So we need to handle the storage, we need to handle some failures, and handling failures can be difficult in terms of figuring out on which stage something failed, because again, we have this lots of moving parts. They are very critical because it's one of the financial pipelines. Therefore, when something breaks, everyone come running straight away. And it influences a lot of teams. And there is one more interesting challenge which arises from that, which is called historical data reprocessing. So it's, I would say, very broad topic. But just in general, when we have some issue that influences business rules, or we want to introduce some change, which would influence the end result for business users, they don't want to have it introduced straight away. We can just merge the pull requests and run this change in production. They want to have it according to some financial time periods. So, for example, if they want to run it either from the beginning of the month or the beginning of the year. It's rarely a year because it would be too much data to reprocess. But usually, beginning of the month. So, for example, if we would have an issue on 10th of December, we would need to reprocess the data back to the 1st of December and rerun the whole pipeline. Why it's a challenge is, again, because of the volumes of the data. So reprocessing may take a day, 2 or 3. And also it has, for now, a lot of manual steps. We are kind of trying to automate it. And manual because reprocessing is just about deleting the old data, introducing the change, rerunning the application, generating new data, moving it from one data storage to another, and showing new data to the users. So it's kind of a lot of steps behind the scenes, but users will just see new data in the query engine. As for the conclusions, as you can see that big data technologies can be used in multiple spheres. In advertising, they help to solve a lot of issues. And I would say not only new challenges, but all of the kind of old challenges that always went before. And it works also in financial sphere, as financial part is part of any company, I would say, because you always need to run some kind of report. So I can say that there is always a way to apply big data technologies, in my opinion. Thank you for attention, and I hope it was useful. Here's links to my Twitter, GitHub, LinkedIn. I will share the slides on speaker deck, and we'll reshare them in Twitter as well. Thank you.